says determine the oxidation state of carbon in each of the following. So we have carbon monoxide, carbon dioxide, carbonate, and just carbon. So one thing we need to remember about oxidation states is that the oxidation state of oxygen is -2 in compounds. If it's an element, all elements have an oxidation state of 0. So if you have O2 oxygen, the oxidation state is 0. If it's oxygen in a compound, it's -2. The other thing to remember is that the sum of the oxidation states equals the charge on the species. So in this case, the charge is 0, and 0, -2, and 0. So the sum of the oxidation states equals the charge on the species. And then you just have an algebra problem. So the oxidation state of carbon is your X, plus -2 for the oxidation state of oxygen equals 0. So the sum of the oxidation states equals the charge on the species. So in this case, carbon -2 equals 0, carbon equals +2. Let's look at carbon and carbon dioxide. Same thing here. Carbon, which is X, the thing we're trying to find the oxidation state of, plus 2 times -2. Two oxygens, each with a -2 oxidation state, equals 0. So we have carbon -4 equals 0. Carbon equals +4. Let's look at carbonate. Here we have carbon plus 3 times -2 equals -2. Note that in these two, the charge was 0, so we set it equal to 0. In this case, the charge is 2 minus, so we set it equal to -2. The sum of the oxidation states equals the charge. So here we have carbon -6 equals -2, plus 6 plus 6, carbon equals +4. So carbon is +4 in both of these two examples, but it's +2 in this example. Here you have carbon as an element. The oxidation state of elements is always 0. So here the carbon is 0. So this is how we can find the oxidation state on the element other than oxygen, in this case carbon, in different examples.